my pleasure to be here this morning in Stockholm, Sweden, and to give this presentation on the artificial intelligence in pancreatic cancer and from the imaging point of view. So, as Matthias said, I'm part of the PANC-AIM project, which is another Horizon project, which also is aiming to develop artificial intelligence to detect pancreatic cancer. And a very important aspect of this PANC-AIM project is the clinical connection. That what we do there in that project is supposed to end up in the clinic or will have a clinical feasibility. So again, I would like to disclose that I am part of the PANC-AIM project and I have received funding from it. I figured the best way to illustrate what I'm doing and what a lot of people at the PANC-AIM are also doing is to show a clinical example, because we are right now, as you can see in the figure on the right, moving towards the end of the project, but we are now in the stage where we have developed a certain set of models and we are evaluating them. So how does this look when we do it? Let's look at a clinical case. So consider the following. There is a 65-year-old woman that appears at the clinic with abdominal pain. The patient history, she was operated in the 70s with a Billroth 2 surgery because of GI bleeding. She was reoperated later, and the surgeon then did a splenectomy. The patient now presents at the clinic with reflux, vomiting, and nausea, and also dehydration. And judging on those initial symptoms, one might suspect that this is something within the field of surgery, more precisely acute surgery. This is also a very common patient group, and usually they fall under what goes by the term of small bowel obstruction. So what you can see here, or you might not be able to see it very clearly because it's a little bit small. I had to adjust to fit into the PANC-AID work package PowerPoint template, but it's exactly how a radiological report looks like when it comes from the radiologist, and under you can see a slice, an axial slice of a portal venous phase. Now, what you can appreciate on this phase is you can see that I don't know if I can show the cursor. Maybe I can just point. The ventricle here, the stomach, is filled with contrast. So not only has the patient received intravenous contrast, there is also peroral contrast. And you do this when you suspect that there might be a small bowel obstruction or something in those lines. The patient or the radiologist finds that there are some signs of dilation of the intestines, and it might be in a case of small bowel obstruction. Nevertheless, the patient is treated for it and returns home safely. The problem, however, is that the patient keeps coming back with the same kind of symptoms. And in the reports, they always look for the small bowel obstruction. They certainly do take a look at other organs as well, but when the patient presents at the clinic with these symptoms of vomiting and nausea, the most alarming thing to look for in the beginning perhaps is either bleeding or ischemia or small bowel obstruction. So that is the main focal point in what they're looking for, the dilation, which they subsequently do not find when the patient comes back. But they nevertheless treat it anyways, because sometimes you don't go on the imaging, you treat patient based on the clinics. But the patient keeps coming back. And the radiologists keep looking for the same thing. However, they do not find any signs of herniation or small bowel obstruction or dilation of the small intestines. Now, there's also the problem that the patient is complaining regularly of epigastric pain. The patient comes back at the end of the year, and then the radiologist sees something else. The radiologist sees signs of low attenuating changes in the liver. And when they see this, they take a very, very long and in-depth look at everything else. And then they find something suspicious in the pancreas. The ducts are dilated, there are soft tissues which are a little bit too prominent, and there are also veins which are appearing strange on the images. So what we try to do in PANC-AIM and with the research at Matthias' lab is we develop the models which can detect pancreatic cancer, in this case imaging, not only at the time when they have pancreatic cancer, but also at the earlier stages when it might not be so apparent, at least not for some radiologists. So what you can see here is
the radiological reports, but you also see a kind of white boxes where I have blurred out what the AI has said or indicated when I have exposed these examinations for the AI. Now I want to clarify, I did not expose all examinations at the same time to the AI in the same manner you would look at them as if you were in a multidisciplinary conference, because then the radiologist, the oncologist, the surgeon, the pathologist, they would all look at all of these series and make a decision based on the timeline. The AI has been only given one examination per judgment. And this is a very important distinction to make. Nevertheless, the model, and I know it's difficult to see, I will illustrate it very clearly later on, but it suspects an area in the corpus of the pancreas, so more in the body. And it does so already in the beginning, at the first examination, which occurred almost 1 year earlier. So when I write that it suspects an area, it's based on my interpretation of the AI segments or what the AI highlights visually. Now, how does this look? So here we have the same the same examinations, but with the heat map on the series underneath. It's the exact same slice. And the heat map represents what the AI is giving attention to and suggests what could be the tumor or a solid change in the pancreas. And as you can see, with time, it's growing. And when you have all of these examinations at your hand, you can perhaps in hindsight say that it was possibly possible to see it from the beginning, maybe if you had looked really, really closely. Nevertheless, in this case, the patient had already had the disease grown too much, it had spread too far, and the patient never became a candidate for surgery. But perhaps the patient could have become a candidate for surgery had the cancer been identified in time. Now, one important thing here is that early detection is the primary goal, but it's not the only goal. And that's something I've personally come to learn during the Pankian project and during my clinical works, is that there are more clinical questions that can be answered with AI in imaging, for example. Now, let's say you look at the image all the way to the right when the patient is not operable. What if you could start treatment and see if you can downstage the tumor and perhaps make the candidate a resectable candidate? So then it's important to have an AI or the same AI that not only looks for a tumor or cancerous tissue, but also looks at benign pancreatic tissue and can make the distinction between those two. This is important, as I said prior, to really identify if treatment is working or not. So what you can appreciate at the top is the heat maps for the tumor, and in the bottom you will see the heat maps both for the tumor and for the benign pancreatic tissue as suggested by the AI model. So again, early detection has perhaps the most value, but there are also other clinical questions that can be answered and where AI can be of use for the clinicians. And this serves to illustrate some of those. This is currently ongoing evaluation in the Pankian project by me and Matthias. So what you're seeing here is a pretty much preview of what's coming in a paper or two. The take-home message that I would like everyone here to go home with then is that we cannot make any definitive statement yet. We have to let the validation, the evaluation be completed, and it must be a rigorous evaluation. And it is very important that the clinicians are at the forefront of this, because they understand the questions and they understand the problems that they have. And we have to listen to them so that we can tune these AI models and make them better at helping the clinicians do what they cannot do today. I would like to conclude this presentation with a huge thanks to the team at the Karolinska University Hospital and to Matthias, who is my supervisor in my PhD project. And also all of you for taking the time to listen and to invite me here. So, thank you.
Thank you.